Knowledge graphs can make your machine learning model dangerously good, so let's break down how you can use them in your next project. On the surface, knowledge graphs start out as the simplest idea ever. Essentially, you're just drawing a map of a reality where every object or person or place is represented as a node, and the relationships between them are represented with lines. And the reason people get excited about it in machine learning is that it turns a list of facts into a whole neighborhood of connections. For instance, if you think about a regular machine learning dataset, it's like looking at one person's profile card and trying to guess everything from that card alone. But a knowledge graph is like having that person's friend group, job schedule, family dynamics, and all their hobbies all connected in a web. So when the model tries to make predictions, it's not guessing in isolation, it has much more context. And a direct example of this in machine learning is link prediction. Imagine a graph where all the nodes are either a student or a class, and the connections or edges between them mean a student is enrolled in a class. Now let's say you secretly hide one of those edges and train the model on the rest of the graph. But now the machine learning task becomes predicting whether that missing connection should exist or not. Of course, it's not guessing randomly. Through the web of connections, it can learn that students who took computer science and calculus are also more likely to take statistics, or that students connected to similar teachers or departments are more likely to take a separate set of classes. Through this learning, the model can make the simple supervised machine learning prediction of whether two nodes should be connected or not. Another concrete example with knowledge graphs is node classification. Suppose you have a bunch of nodes that are all different companies, and the connections between them are shared suppliers, shared board members, or shared technologies. And say that some companies are labeled high risk because of some past incidents. You can train a machine learning model that learns the graph structure and understands which unlabeled companies are likely to be risky. And this might be not only because of their own features, but because they might sit in a neighborhood with a lot of other risky entities. This is something tabular machine learning is generally bad at, and something graph-based machine learning can optimize on. You can start with knowledge graphs extremely simply in Python. At the base level, you don't need any fancy neural networks yet. You can simply turn a graph into features and feed it into a model like normal. So let's break it down. Knowledge graphs are a great opportunity to work with a rather unusual Python library called NetworkX. And this is used to build and work with the graph itself. Besides this, we also have NumPy for math and scikit-learn for our machine learning toolbox. Here we're actually building our machine learning model, and all of our nodes are going to be either a student or a class. Then we're defining all of the edges that we want to see in our graph. The first edge we're specifying here is a connection between Alice and math class, and the nodes are created automatically when the edges are added. Here we're defining the learning target for our machine learning model. The labels say whether each student took a computer science class or not, which turns the problem into supervised classification. Then we're converting our graph structure into numeric features. For each student, it measures how connected they are to other students in other classes and creates a feature vector that the machine learning model can actually understand. Next, we convert those feature vectors into NumPy arrays. And we do this just because it's the format that scikit-learn expects from us. And now it's finally time to train the model. We're using a logistic regression model here, which learns how the graph-derived features relate to whether a student took computer science or not, and outputs the likeliness that they did from 0 to 1. Finally, we're outputting the predicted probabilities, showing how confident the model is that each student took computer science based on the graph. And here are the predictions that Alice, Bob, and Charlie are computer science students. This is an extremely simple example of knowledge graphs in machine learning, but they really hold so much power, especially when it comes to neural networks. If you'd like to learn from that full exemplar code, it's linked right here, so save this video for later and don't forget to follow for more breakdowns.